So you've looked at the graphs of exponential functions. Now let's look at the graph of logarithmic functions. Remember that exponential function and logarithmic functions undo one another and are therefore inverses. So if you think back to when we talked about inverse functions, we talked about how inverse functions should be reflections of one another across the line y equals x. So I'm going to take my graph that I have here and I'm going to draw in on a dashed line the line y equals x. So I have an intercept of 0 and a slope of 1. And now I'm going to go ahead and I'm going to draw each of my given graphs here. So the first graph I'm given is my exponential graph. Well, we already know what that exponential graph looks like. Remember, my exponential graph, specifically my growth graph, has a y-intercept of 1, a horizontal asymptote at y equals 0, and it starts low and gets big if it's the growth. And how do I know it's growth? B is greater than 1. So I look something like this. So I'm going to ask myself, how is my logarithmic graph going to look? Well, it's going to be this given graph here reflected. So if I reflect over, first thing I notice is that if the point 0, 1 is on my exponential graph, then 1, 0 will be on my logarithmic graph. If I have a horizontal asymptote at y equals 0, I should now have a vertical asymptote at x equals 0. So I reflect that piece over there, and I should look something like this. And then reflecting the other piece up, I should look something like this. If I do the same thing for my logarithmic and exponential functions when b is between 0 and 1, let's look at what that would look like. So once again, the first thing I'll do is I'll draw in my line y equals x. Again, going through 0 with a slope of 1. And if I look at my exponential growth, we've looked at this before. If b is between 0 and 1, I am decay, which means I'm still going to have a y-intercept at 0, 1, and I'm still going to have a horizontal asymptote at y equals 0. But now I start up large, and I drop down towards my horizontal asymptote. So if I were to reflect that over, first thing I notice is that if the point 0, 1 is on my exponential function, then the point 1, 0 should be on my logarithmic function. I also notice that if I have a horizontal asymptote of y equals 0, I'm now going to have a vertical asymptote of x equals 0. If you remember before when we talked about inverses, I could plot some points, but I'm fairly good at graphing a reflection without the point, so I'm going to skip that particular option. So here's my vertical asymptote. I'm going to go down through my point. Notice that my two functions share a point in common where they reflect over. And then continuing on, there's going to be my logarithmic function if b is between 0 and 1, so my base. So let's go ahead and summarize that. When I'm looking at a logarithmic function where my b is greater than 1, I'm going to say that my domain, and I know I can't put mine on the same page, but hopefully you have the notes so you can see yours. I can see that my domain, because of that vertical asymptote, is all x values greater than 0. Because of the vertical asymptote, I never actually touch 0. My range, on the other hand, goes all the way up and all the way down. Therefore, I'm going to say my range is all real numbers. And I notice that I have an asymptote. If you look at my graph, I know that I have a vertical asymptote at x equals 0. And I have an x-intercept at 1, 0. So just picking all this off my graph, because of the vertical asymptote, I have no y-intercept. And then just again putting that kind of graph into my notes so I have that handy. I do look something like this. And of course, all my shifting rules do pertain to my logarithmic function. And then, let's see if I kind of made this a little messy. There we go, that looks a little better. And now I'm going to go ahead and look at what happens when b is between 0 and 1. Again, just summarizing that graph I already made. My domain, very similar. It's still x values greater than 0. My range is still all real numbers. And I still have a vertical asymptote at x equals 0. The difference is here my asymptote stretches down towards negative infinity, while here my asymptote stretches up towards positive infinity. My x-intercept is the same, it's 1, 0, and once again, due to my vertical asymptote, I do not have a y-intercept. And then just summarizing what the graph looks like, I still have an x-intercept. Passing through my x-intercept, I look something like that. So again, all my shifting rules will pertain to my logarithmic functions. So what happens when I add or subtract on the inside of the function, add or subtract to the outside of the function, multiply a negative on the outside, on the inside, multiply the outside or inside by a value either bigger than or larger than 1. So just once again, make sure you have those shifting rules either in your notes somewhere to reference or you've already got them memorized.